Hi, so we're working on Advent of Code, Problem 11, Part 2. What we did in the last episode is we refactored Part 1, and then what I did that isn't in a video is I went ahead and solved Part 2 as just an extension of what we did in Part 1, because I knew that would work if we just recursed on incrementing in each direction that we were going in, so diagonally up and down. And that ended up working. Unfortunately, the challenge there was that, or what I ended up with was a lot of functionality, and a lot of it not related to the core business problem of deciding the seats, and ultimately, not a very satisfactory, concise answer, and one that certainly might even have a bug somewhere. So I want to take a moment to try to see if we can't reflect on the entire problem from a different perspective. Not just being driven by what's next, what do we need to do, what do we know we can do, but examining how to say this concisely. What we need to do is see if we can take this problem and generalize it, or generalize aspects of it, and reduce it into a formula and then encode that formula, rather than sort of push ahead with what would make sense to do next. And it isn't the case that we didn't do that in the first. In part one, kind of what we came up with, I think, is almost reasonable. In fact, I'd be confident that it's pretty close to reasonable. But for part two, I think just something about the recursive nature of what I came up with ended up leading to a lot more note keeping than I had expected, and that led to a lot of complexity. So what we're going to do here is essentially see if we can't envision the problem another way and see where that leads us. So what did we have before was, or what do we have is, again, this idea of a grid. Let's get closer here. And let's make sure the grid is a little bit awkward. And we're given a spot, which the problem never had a symbol for that. Well, we're not given a spot, but we need to think about it as if from a given spot, looking in these various directions. Oh yeah, so for problem 2, the simplifying the problem statement, but before, so in problem 1, what we had is you start at a spot, and then you look at the adjacent spots, and you just consider those, right? So the only thing that's changed here in problem 2 is, beyond that, we're now looking as far as you can go. And so for these immediate ones here, these are all exactly the same. The only thing that would change here, and this is notable, is that you would go all the way, right? You would go all the way down to here to check. So for instance, if this, let me mark this one specifically. Let's say this is empty, and this is empty, or not empty, excuse me. This is a floor, and this is occupied. So in problem 1, the answer to this would have been just to consider this floor. The dot is a symbol for a floor. Wow. It's a problem with these tablets that you can rest your palm on. So the answer here would have been floor, and we would have considered this empty. Would have been considered empty. So you would have, any rules that applied to empty here would have applied. In version 2, you would look all the way down here, and this one would be considered occupied. Right, because you can, I guess the one to humanize the problem, you could see to the occupied seat, and that would bother you. So you consider the seat below you occupied, or that's one way to sort of personalize the problem. But really, you could see at awkward diagonals too. So the word C doesn't really capture it. I've been calling it a star pattern, but even that's not helpful because people, might not have the same idea of what star pattern means. So really, I would like to avoid calling it something, and maybe, if I couldn't come up with a good word, I'd actually link to like a picture like this in the docs. I think that would be ideal. If you can't describe it in a word, maybe at least draw a picture. If you feel like you can do a better job visually. So, and then just leave that in the doc, like a link to it, like a Google Doc or something. So, and then again, and so in problem one, what we did is we just found these adjacent spots, so all of these guys. And then I just iterated to go further until I hit a nil, or I hit what I needed. And, that solved the problem and it was acceptable in the time constraints. So maybe I'll push that code up. But it's like really awkward to look at. Like you really only want to look at like 2 functions in it, and the rest of it is like just getting things into place. But there's a lot of that. So I just want to see what happens if we think about this another way. And the one idea in the back of my mind when I was making changes is you can always view a grid as just a vector. And in these problems where you're having to do math, usually the math ends up conflicting with the indices. I can't say that a better way, but basically in this one, this is a 3 by 1, 2, 3, 4, 5. This is a 3 by 5. So we would need to go from, and this is a good shape too, because we don't want, if the rows and the columns are the same, you can kind of trick yourself, I found, unless it's supposed to be a square, and then which ways problems are usually easier. Also, more things work. There's more like abstractions you could use with a square that at least come to mind for me. So in this case, we're going to go from 1 to 15, and I'm going to start at 1. So we're just going to have to, at the end of the day, translate back to 0 to actually get things out. Oh, and so writing here was kind of useless. I'll keep it though. What I really wanted to do was redraw my square and give myself some space. We can just leave all of this actually. 1, 2, 3, 4, 5, 2, 3. Okay. And then I don't need to really fill in because there's already a grid there. Okay, some bookkeeping. Okay, so now what do we need to do? Well, it'd be good to highlight an awkward example, I think, of what this might look like. So, or at least, if we pick, always pick like the smallest case first, because sometimes, that's easier to immediately see these edge conditions in. So I'm just going to pick number 1, right? And then let's pick a color for each. How do I want to do this? Let's pick a color for each direction. So we're going to do blue as start, and then green, I guess, is this. It's kind of good to like highlight out too. Let me just get one. Because we just want to that's fine. And then just another color for these guys. And using the colors here is something I'm doing because I want to avoid naming things. Yellow. That seems too close to the other color we have. What do we have? Green, blue, gray. I mean, you can't tell our one is blue anymore, but you can tell what the other ones are. I should have been marking these down. Close enough. And then what are we missing? Yellow, green, red. And then I'll just write in black. So this is our start. We're not going to give these names. So what's going on here is we kind of want to describe, we want to create a function that would give us back these numbers, right? I mean, it'll give us, for this case, it'll give us back these specific numbers, which will help focus us. And then in the general case, would give us back another one. And I think we can probably, I mean, if it works for 2 examples, I think we'll feel pretty confident that our formula is correct. So we'll have to test this one and then one more. So let's do the easy ones first, and I think it's going to be pretty clear right away what the easy ones are, meaning left to right and top to bottom, because it's like left to right is right away the easiest one, right? Like, why are we starting with 1? It's because that's the row we're, so the first number, I guess there's 3 parts to this, right? Our start, our stop. We don't want this blue thing, actually. That's our example. Start. I'm gonna leave some space here. I think that's good to, I mean, we might need more space to describe things, but for just writing, we probably won't. Let's zoom in so I can write better. Stop. And, okay, do we need to start and stop? Because, I mean, maybe just step, and then if it's, no, because if it's a, right, there's some cases where if you don't stop, you would get the wrong thing, because like this one, like if we're following yellow, 1 to 5 to 9 is, like for this example, it's +4, and there is a 9 + 4 on this, right? So even though visually, because eventually we're, like these, the way I've numbered these right now is how they're going to be in a vector, not in a vector of vectors, right? They're indices that we could translate. I mean, it works both ways, but the point is, let's just see if we can get the stop, because if we do 9 + 4, we'd get 12, and then that would be valid. Like, we would do it like a curve, and that's not one that would be considered in this diagonal. So I should move my mic up rather than crouch down. Yeah, so right now, if we're doing a single vector, which is kind of like, it's making the problem different than we did it before, which is hopefully going to somehow reveal something. Then get some lines in here. It's good to have these, spaces, because then, of course, nothing lined up. Let's make it so it does, and then we'll add red back in. This kind of visual space, it helps focus, right? So kind of like where, even if you're spinning your wheels, where you're spinning your wheels, and you can be more precise about that. Okay, so green is easy. Is it easy? So what is stop? What is 1? 1 is our, because what we're going to be given is like a row ID and a column ID, right? So we should write, okay, let's describe this grid. I mean, I think it's probably just the 2 numbers, right? It's a, we can use acronyms here, row. I guess, the simplest way to rate is a 3 by 5. So if we want to think about this as column and rows, there's 3 columns, there's 5 rows. And 1 is, so what we're given here, like the one we selected is, let's do it row by column. Let's just have that be our convention here. And this is why I don't like doing tuples, because even though it's like there is a sometimes it's more convenient to think of it one way versus another. And if you do a tuple and you don't label things, like a data structure where there's no labels, everything should be treated the same, in my opinion. So I don't even like it when there's and I did that on my last problem. I used a tuple for row and column. So the size is I'm sorry, space out for a second. There's 5 rows and there's 3 columns. And then I want to draw a line there because what we're given is our 0, 0. Which we're doing is row, column. At least so they like are the same, which is not how we did in the last problem. So how do you get 1? Oh, it wouldn't be, our location isn't 0, 0. Right, because I was just having a moment because I was like, well, what they'll give us is 0, 0. That's the index in our vector. But like I said, if you notice, it just makes the numbers match up a lot better if you just increase by 1 when you're dealing with the math. And that's why it should have been this way. I don't know. I remember reading the history about like why we started 0, and I think it's like is it $1 billion mistake? I don't know. We'll never know because I can't imagine all the things that like, I'd have to go read his reasoning, but I feel like it ends up not being great. And this is maybe one area where I don't know. I'm not gonna even, I'm sure it's been talked about and I have nothing to add to the conversation. But we're gonna call it 1, 1. So this makes it really easy to see why it's 1, 1, right? Because it's, what would be the other? If we were given 3, we would be, and it was row, column, it'd be row 1. Let's label these. So it'd be row 1, column 3. So it almost looks like they're multiplication, but I think 4 is going to make that immediately obvious that's not the case. So this is 1, this is 3, and if we're given 4, it would be row 2, column 1. So it would have to be your row, I think the formula's got to be something like row nth times row size, because our row size is 5, which you wrote up there, so that would be 3, 2, no it's not, yes it is 3, 2, this is not going to be right, 6, this is weird because this is like something I feel like I've done a dozen times and now I'm trying to understand. So like what I'm saying is that, do I need to do this? I might be solving something that isn't relevant. No, because we need to get the starting position. No, we don't. We're going to be given 1. I am thinking about this wrong. I'm trying to solve some problem that doesn't exist. And that's why it's making no sense. It's because like in my mind, we were going to be given... oh, what the hell? I don't know what happened to the video there, hopefully nothing weird. in my mind, we're going to be given a row and a column and have to turn that into 1, but that's not going to be the case. We're going to be given 1. So we're going to be given but in the case that we're given, where would this not work? 1 is the starting place for all of these. So maybe we shouldn't start with that. Because, well, I'm sorry, what I'm thinking about is that if we actually start with 5, then we have to find 1 if we want to start. So I almost want to, like, can I copy this really quick? Can I copy this whole thing? I just don't think it's a good starting place for hopefully this doesn't take more than like 30 seconds. Yoink. Just a matter of erasing all these. Yep, too much. Need to be consistent with the colors. And this is fine too, because we knew we were going to do 2 examples. So I'm going to choose 5. Don't need to highlight the middle one. It's obvious because it's where they all meet. So what am I on about here is that if in this example I guess we'll write what we know we need to get like right here. We knew we need 1. And so in the previous one it was like easy because that's what we're going to be given, and for like half a heartbeat I convinced myself that was okay. So we need to go from 5 to 1, and in this case, that transition is obviously a matter of subtracting the row. So the row is 3, and we go back 5 minus. Oh, and because if we're okay, I'm sorry, I'm concentrating on. I'm looking at the wrong. I was looking at gray for a second, and we're doing green. Let's use 5. It's in the middle. I think this is going to be better than 1, but we'll check with 1 too. So our start we know it needs to be 4. Let's fill in these things, and the end is 6, and our step is 1, and we know this is already the increment. The function is 1, and we know the function is going to be inc. So this is like already set. That one's easy. Increment and decrement. So if we're starting from 4, then it's just increment all the way to 6. Because in this, what we're trying to do here is we're trying to not have nils. So we're gonna like try to discover the start and the stop, which should be totally possible. I mean, I know it's possible. I just feel like somehow the math is gonna be, just annoying enough. Like, and every single one's gonna be like a little bit different. Because I don't think there's a relationship between moving like diagonal versus moving straight on a grid. There's no there's no unifying thing there. I mean, the numbers changing is probably like a unifying thing. That it's a sequence is a unifying thing, but so how do you know 4? Well, because 4 is the it's the second. So there's 3 things in a row. And so 2 times 3 is 6. So that would be the end of each one. So I guess you always know the end. The stop is row is multiplied, so it's going to be row size times row end. We're going to use size times row n. Is that true? Let's check another one. I mean, this 3 times 3 is 9. Yes. Things work out for that, so we're pretty good there. And then the start for the green is 4, which is 2 times 2. But that has nothing to do with the row size. It's the first thing. So it would be your row size. If we were doing 8, it would be 7. I didn't write my numbers at all in the grid lines, which I'm now realizing makes this really hard to look at. I can change that. I can move them. I didn't like line them up. Okay. Much better. So it's got to be multiplied by your nth row. That is a fact. But in what way? So we're in the second row, so it's going to be 2 times something. And it would be the length of the column. And then we have to subtract 2. It's almost like the end minus one less than the. Would that work for all of these? We'll just write. Okay, we know we want 4. So if it's stop, we zoom in. Minus, so that's 6. And then it would have to be 2 equals 4. And why would it be 2? 1 less than the size of the row. Minus 1, which is 2. 6 minus 2 is 4. 4. Does that work for another one? If we're 9. 3 minus 1 is always 3 minus 1 is always going to be 2. 9 minus, yeah. Okay. Okay. Yeah, I mean, like in my head, I'm not sure. If we had a row that was, if we just had 2, 1, 2, 3, 4, 5, 6, 7, 10, and so this is 2 by 5. Is that how we did it? Yeah. Then we chose 10. 10 minus, and the row size is 5. 5 minus 1, so 4, 6, 6, and that's the one we want. Okay. I'm convinced, despite it just feeling kind of like there should be some fancy word or formula to describe this, that seems right. And again, to be clear, this seems awkward, but like I did the recursive version and that was very awkward. And this, like, knowing, because right now what we have is 4, 5, 6 and we can produce that. Now we can just ask the grid to give us those, and then ask the question that we need to ask directly on that. Like, we can collect all of these numbers into a set and then boom, ask it. As before, I had to do this like recursive call to expand outward and do all this note keeping to make sure we could continue it. Like, you know, it's awkward either way until we watch a video where somebody just does it in like one line. Okay, so green is done. So theoretically, this is like 1/8 of the problem. Hopefully, is done overall. And then red, we'll write our numbers that we know we want at the top to 14, and the step is 3. I feel like step is always going to be let's start with step again. That was obvious before. And so step here is the row size, right? And that makes sense. It's true, and it's also like mathematically true. You're just progressing the size of the row each time when you go down. So plus row, and we're doing RS as row size. Okay, and then the stop is 14, and this again is going to have to be, there's going to be multiplication involved because we're going to need to like take definitely the row size we're at and multiply that by the row column, and if we just do that, the answer is 15. And then what do we, we're going back 1. Because we're starting from, if we do 3 times 5, and then it's like you have to know how far you have to backtrack based on the column that it's in. And so we know like we're 1 column back, but we don't, how do we, like 5 doesn't tell us we're 1 column back. This is awkward for some reason. 2. Hold on, I'm gonna pause and think about this offline. We did it for green moving across, so we should be able to do it for red too, but it feels as if like the formula here always needs to involve some sort of boundary. You know, in our grid case, there was a vectors, it was nils, and in this case, it's simply knowing that there's only 5, and you can't go further. Like there's only 5 rows, and you can't go further, because like if you're looking at this as a sequence of increasing by 3, like that by itself has no, that would just go to infinity, right? So you have to have a boundary condition, and you provide those. Those aren't like, we have that in the problem, so it would just be a function that keeps taking 3 until it the last number before 15, starting at 5. So it's like, what would that, you know, I mean, you could, oh, I think my tablet's gonna die. It went black. I think it is low on battery. I'm gonna disconnect my tablet and then start charging it. And I think the moment, that's fine, because we can go over to our coding part for a second and see if, like, it's weird though, because for the row when we just convinced ourselves we could figure out the condition, but I just want to see if we can. So it's like starting a number, start, stop. This looks a lot like range. And are we giving the start and the stop? 5, and the stop would have to be 15, and the step would be 3, would be step. Yeah, well, I should just write range. Yeah, is this just gonna work? Range. Well, no, because 5 we need the one before it. Step can be negative. Five, 15, 3. Step can be negative. Can it? This might be, I would hope Python can do that. Closure, slipping. Wait, it just had a, oh, because it wouldn't be, I'm thinking about how to do this. Start, stop, -10. It would be 0. Wouldn't it? Yeah, because you'd always just hit 0. Oh my. So this is, thinking about it this way is even easier. Would that work for our row too? Because our row would have been 4, 5, 6, and in which case we always just do the start as the 5, and then, but how do we know 4 is where we need to stop? How do we know 4 is the start? No, I mean, we know, or how do we know 4 is the end if we're moving backwards? Right, 4, -1. That's not what I expected to happen. Should have had 4, 5. Does it, because it doesn't go to it? Okay. It's up to the end. So it would even have to be -3 because we want 4. Now, so what I'm saying is that, like, I'm picking 3 here, but that's because I know the number. And why would it be 3? What is 3? 3 is, like, my tablet died, so I'm gonna write out the numbers. And 3 is just the, we're in row 1, 2. So it's our row column, our nth row. Oh, it would be the last number in the last row. So it would always just be dec, and ours is 2 times row size. Let me write this out in a let block. You know, let's not. Let's just put it right here where it's being used. Dec 2 times row size, which is 3. Gotta start labeling things, or we'll lose track of them. And this is up, down, and then for left we're gonna start at 5, and we want to continue. And here the trick is, we don't need to no. Right, we just need to increment all of this. Okay. Wow, so this is actually not how I thought this was going to go, but I'm realizing, I think somehow in my head, my ranges, I had like sort of forgotten that there's an easy way to decrement backwards, and that ends up simplifying how at least I'm thinking about it, because it's easier to just do it this way. And this really leaves us with the diagonals. And again, we're going to be, we'll do up left, there's going to be 4 of them. Actually, let's do up right, because I read. That's how I always think about it. Down right, we'll go in a circle clockwise. Down left. Down right. Let's see if this just falls into place for us. And then as always, we're starting at 5, and we did this in the previous part 1, where we know that basically what you're doing is you need to go up, you're always decreasing. So it's like the row before. So whatever row you're in, 1 less than that. And how do we know what row we're in? Is so what number would we want first? Let's just put it there. Like we're starting at 5, we're stopping at, this is where the grid would be nice just to help focus. Yeah, let's wait for the tablet to be back up, because it's so much easier for me when I can just look at the numbers really quick and then use that to double check. So, and my tablet died, so I'm gonna go like exercise and come back to this problem.